Let's start. And before we talk about artificial intelligence, let's take a look at the most intelligent machine. Uh, I'm saying most intelligent because it learns the fastest. In early times when a baby is learning, whether it is learning language, whether it is learning movement, whether it is learning anything. So it's like babies learn very fast. Okay. So let's take example of baby to kind of like actually understand how we can place AI, how we can place machine learning, how we can place deep learning, how we can place maybe reinforcement learning with the example of a baby. You see, because baby, there is no curriculum in the world which is teaching babies mathematical formulas. So the baby, every learning which is done by baby is learned from data. And there is an experiment happening. I have forgotten what's the exact name of the experiment. The experiment is they have actually fitted baby with few sensors to actually record every single thing baby hears, every single thing baby sees. Why? Because they want to figure out how much is the volume of the data on which baby's brain gets trained on, and maybe we can figure out how to learn from that data. So there is an experiment happening which is doing that data collection, just to give you an interesting trivia. Anyways, for now, let's take a look at machine learning. You see, AI. What is concept of AI? Concept of AI is simple. You learn from data. That's it. You learn from data, not from the logic, but you learn from data. But how do you learn from the data? That's a completely different thing. Okay. Now let's see how is machine learning doing. So machine learning is also learning from data. But in machine learning, there is one key important part, which is model. So this model in the background is a mathematical model. Okay, in the background, it is a mathematical model from which machine learning is learning. Okay, so you see, language. Whenever a baby is learning any language, is there any mathematical model of the language? Answer is no. Whenever a baby is learning to see something, is there any mathematical model for vision? Answer is again no. Then what is a mathematical model which baby learns? The first mathematical model which a baby kind of like learns, maybe you could call it as a table of numbers. So when we say it's like let's say I wanna find out number, the table of let's say 12. So babies actually learn machine learning towards when they actually start school. Let's say they are learning multiplication table. Let's say we are learning multiplication table of 6. So 6 into 1, 6. 6 into 2, 12. 6 into 3, whatever, 18. So it's like this. So once baby learns multiplication table, it actually understands that the number is replaceable. This number could be any generic number x. If you want to find out multiplication table of x, it is going to be 1x, 2x, 3x, 4x, 5x, something like this. So this is a generic mathematical representation of multiplication table. A baby, when learning school, baby doesn't know that this is how machine learning actually functions. You have a mathematical representation of something. Now you can actually have mathematical representation of anything. Okay, let me just show you if you want to find out. So curve of Batman, let's search this. So from Wolfram Math World, you will find there is a mathematical curve which can print Batman's logo. So this is the curve. So if I just open this in a new image, oh, this is actually two on the black background. But yeah, so if you want to create a Batman curve, this is the curve of Batman. Okay, so is this mathematical? Yes. Okay, instead of Batman, if I make a very interesting kind of like different kind of curve, so General Agnes witch or a egg, or let's see pretzel curve or plateau curve or pearls of sluice, or what do we have? or Newton's diverging path, or like this. Okay, so you have different kinds of curve. So these curves, you see, they have a complicated curve will have a complicated equation, right? Eventually, when the curve or the mathematical model becomes too complex, wait, eventually when the curve, the mathematical model becomes too complex, why will it become too complex? Because there are too many rules. A simple problem has a simple equation. More complex problem has a more complex equation. And in machine learning, we are choosing the model. So we will have to find out models in an incrementally complex way. Now there is a limitation to it. So there comes this thing. So for example, let's say I want to create an infinitely complex drawing. Every drawing can be created by summation of infinite small lines. I could kind of like combine small lines in any way to create any complex thing. So what is deep learning? Deep learning is what, let's play on word deep. Let's say when the learning to be done is so deep that the simple model in machine learning is not enough. The things to be learned is so deep, so complex that we need a different approach. That is deep learning. In deep learning, we just give data. So in machine learning, we give data, and on data, we give in the model which we choose. Whereas in deep learning, we give data and we give something called as a network. What kind of network? Blah blah, let's not talk about it. In deep learning, we just give a network, and to that network we just give in data and it learns from it. The reason we are giving example of a baby here is, in the previous example we talked about multiplication table. In this example, let's talk about the second thing baby learns. Generally it's A for an apple. So A for an apple, B for ball, C for cat. Let's think in terms of baby. Okay, a baby is able to see few pictures of different cats, and then baby learns all kinds of cats in the world. In terms of number of species of cats, I am sure there will be more than thousands. Whereas dogs, they have more than tens of thousands species. So let's take dog, so D as a dog. So a baby learns what any kind of dog looks like simply by looking at a few pictures. So what does a baby have? The brain is a kind of a network. So we try to create a similar network, and that network is generic. Okay. So we give to that brain, say, oh, these are few apples, these are few balls, these are few cats, and these are few dogs, and learn from them. Learn what an apple looks like, learn how a ball looks like, learn how a cat looks like, learn how a dog looks like. I search for a curve of Batman, but if I search for curve of cat, I probably will not find it. Curve of let's say dog. So this is going, so mathematical curve. So mathematical curve. So we will not find a mathematical function which is gonna print dog. Maybe you see, you can't find, because this is too complex. That's where deep learning comes. When the problem is so complex, when it has so many factors that a simple mathematical model is not enough, then you come to deep learning. Then let's think of another example, which is reinforcement learning. And reinforcement learning is a good example because this is the first thing baby actually learns. How does a baby learn to walk? Or how does it learn to crawl? Have you seen, so in sports, you have coaches who are teaching you a sport. Have you ever seen a person telling themselves, oh, I'm a walking coach for a baby, oh, I'm a crawling coach for a baby? Have you ever seen people specializing in such behavior? No. Have you ever seen a parent teaching baby, okay, To crawl, you have to take a leg like this, you have to do like this. Is that how crawling or walking coaching is done? No. How does a baby learn to walk? It is extremely simple. Trial and error. So you try, you see what works. What works is like if you go forward, and what is an error if something hurts. So trial and error, it's like you have a feedback. So if you're trying to walk, you do something and you fall down, you kind of like understand that whatever I did last time leads to me falling down. After I fall down, it hurts. So let's avoid doing that. Let's do something else, see what works. So see what works. That is the definition of reinforcement learning. There, if you go into details of this, there is an environment, there is an agent, there is a fitness function. That's a lot of complexity. We don't need to go into that. Similarly, in complexity in deep learning is there is data, there is neural network architecture, there is learning rate, and all this complexity we don't need to know. All we need to know is A for apple, B for ball. That learning is deep learning. Learning of walking through trial and error, that learning is reinforcement learning. And multiplication table or anything like this, that is machine learning. You see, now let's talk about types of data. As long as there are number of rows and columns, generally there are number of rows, numeric data, numeric columns, generally that's a good choice for machine learning. Why? Limited number of rules. You actually have a mathematical model, right? When the data isn't too complex, when the rules aren't too complex, machine learning works. When we are doing deep learning, when is it required? When the data is generally of human senses. What all senses do we have? We have ears to listen to stuff. We have eyes to see stuff. We have mouth to speak stuff. We also have other senses like taste or touch. But there are no sensors which actually translate that to digital format. So for now, these senses, vision, audio and video and stuff like this, that is generally best done with deep learning. So whenever you are working with text, it's a safe bet to say that it's generally gonna be a deep learning problem. And whenever there is a trial and error thing, let's say for example, a robot needs to learn mining. That's a hard problem. Trial and error. You can't manually teach everything because you don't even know how it's happening. So reinforcement learning. So we saw 3 different ways of learning. We also saw examples of these 3 different ways. So you can actually choose based on the problem, what is it that you need for that problem to solve it. So in next lectures, we'll see other details which, are part of this whole machine learning ecosystem.